So we're looking at invertible matrices. This is video 3 in the series. And we want to look at a theorem that tells us properties of the inverse. Now, these are 3 important properties of the inverse. Now, let's say you have 2 n by n matrices that are invertible. So suppose A and B are invertible matrices let's say that are n by n, same number of rows as columns. Then first of all, A inverse is also invertible, and A inverse's inverse is A. Second of all, if A and B are invertible, and they're both n by n, then A times B, that resulting matrix, is also an invertible matrix, and A times B inverse is B inverse A inverse. In other words, you can say that as the inverse of AB, the inverse of AB is the product of the inverses in reverse order. So how do you say that? The inverse of the product is the product of the inverses in reversed order. And finally, number 3, the transpose of A, that's called AT, right? A transpose is also going to be an invertible matrix if A is invertible. And A transpose's inverse is A inverse transposed. All right, let's see if we can prove these properties. They'll come in handy sometimes, on occasions. So in the background, we have A and B are invertible matrices. So suppose A and B are n by n invertible matrices. Suppose A and B are n by n invertible matrices. All right, that's what we're assuming here. So the first thing we want to show is number 1. We want to show that A inverse has a counterpart, right? A inverse multiplies by something to give you the identity. You have to do that on both sides. So I'm going to start with taking A inverse. And what do you have to multiply A inverse by to get the identity? Well, if you take A inverse times A, right, you get the identity. And likewise, if I take that red A and multiply it on the left of A inverse, I also get the identity. So because I'm able to multiply A inverse by something, what is a something? Is A, right? And get the identity, that means A inverse is invertible. So thus, A inverse is invertible because I'm able to multiply it by something on both sides to get the identity. And what's A inverse's inverse? What's its counterpart? Well, it's the thing you had to multiply A inverse by to get the identity. It would be, in fact, A, right? That's what we had to multiply A inverse by to get the identity. Okay, so that's number 1. Number 2, we want to show that AB is invertible, and AB's inverse is B inverse A inverse. So what we're going to do, we're going to start with AB, right? We want to show it's invertible. And we want to figure out, what do we have to multiply AB by to get the identity? Well, there's kind of a hint here. The hint here is right here, right? That dude right there, that dude. Let's try multiplying by B inverse A inverse and see what happens. B inverse A inverse. So I have an associative property. I can associate the middle two, right? The B with the B inverse. I can put my parentheses around the B and the B inverse. And what happens when I multiply those together? If I multiply B and B inverse together, I get the identity, right? And then I can multiply A with the identity, right? And I get A. And then A times A inverse is going to give me the identity. So if I follow this from beginning to end, right, I took the blue AB right here, right? I multiplied by B inverse A inverse, and I got the identity right there. So AB times B inverse A inverse gives me the identity. Now you have to show it works on the other side as well when you multiply by that red B inverse A inverse from the left. So let's say and. Now let's try B inverse A inverse coming from the left side of AB. You can play the same game. You can write down B inverse and reassociate the parentheses around A inverse and A. All right, we just shifted the parentheses a little. Shifted the parentheses. So we're associating around A inverse and A in the middle. What is A inverse A? That's the identity, right? So I'm going to have what? Red B inverse. This right here, A inverse A, is the identity. And we got a B on the end. Okay, so then we're going to take B inverse times the identity. That's going to give me B inverse. Then we have a B on the end. What's B inverse times B? That's going to give me the identity. So if you follow this, this means this red B inverse A inverse times this blue AB gives me this blue identity. So I multiplied on the right by B inverse A inverse and got the identity. I multiplied on the left by B inverse A inverse and got the identity. So that means AB is invertible. Thus, AB is invertible. Right? It has a counterpart that you can multiply on the left and on the right to get the identity. And what's the inverse? What is AB's counterpart? What is the red dude that we had to multiply AB by to get the identity on both sides? It's B inverse A inverse. Okay, so that's number 2. Let me just scroll up so you can see number 2 again. Okay, let's do number 3, which is about the transpose. So we want to show that if A is invertible, then the transpose is invertible. So this is number 3 here. It's not writing. There it goes. So let's look at A transposed. So we want to think, okay, what do we have to multiply A transpose by to get the identity? There's kind of a hint here, right? We know that it's supposed to be this thing, A inverse transposed. Let's see if this works. Now, this is not part of the proof, but this is a little kind of aside here when we did transposes. So here's a little fact. Remember when we did transposes? Remember if we were to have B, A transposed. So the transpose of the product is the product of the transposes in reverse order. So this would be AT, BT. Or you could also do it this way. If I had AB transposed, you could write this as BT, AT. Right? The transpose of the product is the product of the transposes in reverse order. So if you think of this A here is blue, and let's say this B here is yellow. Let's call this yellow right here. And let's call these green. Let's call these green. Notice we have AT, and you can think about this A inverse in yellow here as kind of like the B. So that's basically using that property of the transpose. This is equal to A inverse A with a big T around it, right? Right. Right. The B is yellow, right? And the A is blue. So I'm just using that property of transposes. All right, what's A inverse A? A inverse A is the identity. And we have a transpose. What happens when you transpose the identity? It's still the identity. It doesn't change. Okay, so I have A transposed times A inverse transposed is the identity. So we're able to multiply A transposed by that A inverse transposed to get the identity. And let's see if it works on the other direction. I'm going to take A transposed, and I'm going to multiply on the left by A inverse transposed and see if that works. So let me call these T's the greens. And going to say, okay, this B here, my fact, that's going to be red, and this A here on this second fact is going to be blue. Right? So this matches up, right? The A inverse matches up with the B, the red B, and the blue A matches with the blue A. So we can put this together, a single parentheses with the transposed. So notice that first you're going to get the A, then you're going to get the B. So we're going to have what? A and A inverse. What's A times A inverse? A times A inverse is the identity. And then that's all transposed. What happens when you transpose the identity? You get back the identity. So we have the red A inverse transpose times A transpose its identity. So we took A transpose, multiplied it on the right by A inverse transpose, got the identity. Multiplied it on the left by A inverse transpose, got the identity. So therefore, thus, A transpose is invertible, right? It has a counterpart. And A transpose's counterpart, its inverse, is that red thing. A inverse transposed. And that's it. So you probably want to be familiar with these properties. The one that probably shows up most here is probably the second one. Shows up the most, which is AB's inverse is B inverse.